Hi everyone, my name is Zach, and I work at Huawei Technologies in China. Welcome to this class on cloud. So when I was your age, I was really interested in languages. I went to school for Chinese and Japanese, and I later became a translator. And then later on in life, I became interested in other languages, the languages of computing. So I went to school for software engineering and later became a programmer. The reason I'm sharing this is because I think it's really great that you guys are getting involved in technology at a young age, because I think it's going to be great for your future careers. So what is cloud? Cloud is the foundation of almost all the major technological changes in the world today. As a result, cloud is becoming an essential aspect of a country's national infrastructure, just like clean water, electricity, or network coverage. But I'm getting ahead of myself. Most of you know something about cloud. For example, Google Drive is a cloud service. Amazon is in the cloud business via Amazon Web Services. And at Huawei, we offer cloud computing and storage through Huawei Cloud. So to many people, cloud sounds like something very abstract, like a cloud floating in the sky. So it's not something you can touch, but actually it's very real. It's actually based on hardware. Cloud services are provided by interconnected data centers located throughout the world. These data centers, the cloud, are changing just about everything we do, whether it's studying, working, banking, agriculture, or even travel. So when you watch videos on YouTube or TV shows on Netflix, the video files are stored on the cloud. If you're doing a group project, you share files on the cloud. In hospitals, specialists in different cities can use the cloud to share patient records and provide better care. Modern public transit systems are also managed via command centers, where information is collected, stored on the cloud, and shared in real time with operators and system managers. And even during disasters, like floods, earthquakes, or fires, first responders share information on the cloud so that resources are allocated to those who need it most. There's hardly any part of our lives that's not digitally transforming with the help of high-speed communications and cloud. So how did cloud come to be? In the early days of computing, I'm talking about 40, 50 years ago here, computers were mainframes, those big computers you see that filled up a whole room, and you could only access them through something called a dumb terminal. Now they were called dumb because they had no processing power on their own. Then, in the 1980s, IBM and Apple changed how things work. They released personal computers. So these devices localized computing power. Each Apple or PC compatible device had its own storage and processing capabilities. So users no longer had to access a distant mainframe. Then came the 90s, where access to the internet started becoming widespread. This not only allowed users to connect to each other, but it also allowed them to access data stored on servers around the world. But at that time, it was super slow. I used to get on the internet with a dial-up modem. The top speed was 9,600 bits per second, and I had to stretch a phone cord across the entire house to get on the internet. Now, technologies like 5G are about 5,000 times faster than that. And network speed is really important for cloud. Over the past 20 years, the speed of telecommunication networks has increased rapidly, meaning that the response time when connecting to distant servers is now a fraction of what it used to be. From our perspective, it's pretty much instant. This faster network speed is what makes cloud feasible. Essentially, in a way, it's helped us almost return to the distributed mainframe model where a lot of our computing power and storage is happening remotely. Now, cloud addresses the needs of organizations and individuals and consumers like you and me. For example, we use cloud to easily access large amounts of data and to connect with other devices, such as your home security system or even your car. On the cloud, your data is safely backed in a resilient and secure manner. As for companies and organizations, cloud helps improve resource allocation because you don't need to invest as much in physical IT infrastructure. So in the past, organizations, whether it's a government ministry or a company, they had to have their own servers in their own facilities so that they can control and process their own data. From a cost perspective, it was super expensive. And in terms of efficiency, it wasn't very elastic. If you needed more storage, you had to install more physical storage. And if you needed more processing power, you had to install more CPUs. So a lot of companies, they're occasionally going to need a burst of computing power. For example, say a company that sells concert tickets online. When Taylor Swift announces a new tour, they're going to have a surge of traffic. And if we're using traditional IT infrastructure models, you'd have to invest in enough physical infrastructure to support peak traffic, which means a lot of times that infrastructure is not going to be used. Now with cloud, these organizations can use the resources that they need during peak times and release them when they're done. So cloud not only helps with resource allocation, it can also help minimize carbon emissions. The shared model of resources is not only more efficient, But also the physical infrastructure that enables the cloud can be built next to wind or solar farms, so they're powered with renewable energies. Another solution is to deploy it in cooler parts of the world so that they can consume less energy when cooling all the computing equipment. So that's it for this short introduction to cloud. In this course, we'll look at cloud architecture, how data is kept safe, how data is shared, and also look at some emerging trends in cloud. In the next lesson, we'll take a deeper dive into the advantages that cloud provides.